question number 3 for the 2015 summer examination paper for linear algebra and programming skills. Question 3a is concerned with subspaces of the vector space P3 over R, which are polynomials of degree 3. 3b is determining the coordinates of a vector with respect to a basis. And 3c, we want to show that these three vectors are linearly independent, again, over a vector space of polynomials of degree 3. So for 3a part 1, we have W1 is a subset of polynomials of degree 3 of this form, and you can see that a polynomial of degree 3 belongs to W1 as long as the constant coefficient is 1. Now you should also always show that these subsets are non-empty. So W1 is non-empty, as 1 plus x, for example, does belong to W1. So 1 plus x is in W1. However, you should easily be able to see that if you multiply this by a constant, so for example 2 times this polynomial, then we get a new polynomial, 2 plus 2x. But 2 plus 2x no longer belongs to W1 because the constant coefficient is not equal to 1, which is one of the prerequisites here. So this vector does not belong to W1. So if we took a vector, say u, which is in W1, but alpha u is outside of W1. So therefore W1 is not a subspace. So with this kind of question, you just need to give one counterexample. For W2, we have polynomials of this form where you can see the coefficient of x is 0 and the coefficient of x squared is 0. So as long as you have a polynomial where the coefficient of x and the coefficient of x squared is 0, then that polynomial will belong to W2. So first of all, we want to show that it's non-empty. So the polynomial 2 minus x cubed does belong to W2 because the coefficient of x is 0 and the coefficient of x squared is 0. Now this is a subspace, so we have to prove it's true in general. So we take two general vectors which are in the subset W2. So u is the polynomial a0 plus a3x cubed. So you can see the coefficient of x is 0, coefficient of x squared is 0. Similarly, v is another general vector, b0 plus b3x cubed, and again the coefficient of x is 0 and the coefficient of x squared is 0. They don't appear here. So these are two general vectors in W2, and we take alpha as general real number. So alpha u plus v is equal to alpha times this polynomial plus this polynomial, and we can easily figure out what the new polynomial is. So the new constant coefficient is this, and the new coefficient of x cubed is this. Now again, you will notice that the coefficient of x is 0 and the coefficient of x squared is 0, so therefore this new polynomial does belong to W2. So therefore W2 is a non-empty subspace of P3R. So we took two general vectors u and v, which are in W2, and alpha is a real number, and we showed that alpha u plus v is also in W2. For part B, we want to determine the coordinates of this vector, 4x squared minus 3x plus 10, with respect to these bases vectors. So we want to express 4x squared minus 3x plus 10 in terms of these two basis vectors. So we're seeking coefficients a and b such that 4x squared minus 3x plus 10 equals this right hand side. So if we equate coefficients, then for example the constant coefficient 10 should equal 6a plus 2b. So that's our first equation. If we look at the coefficients of x, then we have that minus 3 is equal to, and we just have a minus ax on the right hand side. So minus a equals minus 3. And finally, if we look at the coefficients of x squared, then we'll get a minus b should equal 4. So solving these equations, you can see that a is 3 and b is minus 4. So therefore, the coordinates of the vector v with respect to the basis b is equal to 3 minus 4. And notice here, we use square brackets to denote coordinates, and this is not a vector. Okay, this is not a vector. It is the coordinates of v with respect to the basis b. And then finally, we come on to part C. So we want to show that these three vectors are linearly independent. So that means that we have to show that a times the first plus b times the second plus c times the third is 0. Then the only solution to this is a equals b equals 0 to make these three linearly independent. So again, we just equate coefficients. So we can see that the constant coefficients, we have a over 2 plus c over 4 is equal to 0. For the coefficients of x, we have minus a plus b is 0. For the coefficients of x squared, we have minus b is 0. And for the coefficients of x cubed, we have minus c is 0. And if we solve these simultaneous equations, the only solution is a equals b equals c equals 0. So therefore, that proves that these three vectors are linearly independent. And that concludes the solutions for question number 3.